This is a video tutorial in Tracker 4.85 to show how you can interpret some of these motions in the right panel, such as the velocity in the x, velocity in the y, and ax. So this is a complex motion of a basketball being thrown, hitting the board and then hitting the ground eventually after several bounds. So this is one of the ways you can interpret the data. So I can check on the velocity vector to allow the visualization of the velocity, because the question asked was how can I interpret the Vx and Vy. So there are many of these values that are difficult to understand. So by allowing the visualization of the velocity vector, you can now see that the velocity vector is quite short. So I make the velocity vector to be stretched by a multiplying effect of 6 perhaps, and see how this can be overlaid on the real video. So you can see that this various arrowheads to show you the magnitude and direction of the velocity, which actually is not shown. So I will toggle the V vector. So you can see at the bottom right corner of the screen, this is actually the velocity vector, and actually the Vx is actually the velocity in the x direction, the Vy is the velocity in the y direction. So you can see that when it hits the wall, it rebounds, it will hit the wall and hit the hoop, and this is where the velocity actually now goes to the positive x direction. So you can see that the Vx now is positive, and the velocity in the y direction is actually beginning to be near 0, but as it falls after the hoop, you can find that the velocity now gets larger, and the Vx is actually quite small because there is no movement of the basketball in the x direction. So after several bounds, you will see that actually the Vx graph is actually quite meaningful, because the gradient here allows you to understand that the motion under free fall undergoes constant acceleration, as illustrated by the straight line gradients in the Vx graph, but in the Vy graph is relatively flat and 0. So I'm going to zoom to fit and teach you how you can normally visualize this. So we normally toggle the x, Vx and ax graph so that I can see all the three quantities in the same direction. So you can see that the x actually is starting from 0 but slowly decreasing, and you can see that it's relatively a straight line. So it seems to suggest that the throwing of a basketball is actually a motion without any horizontal acceleration. And when it hits the board, you can see that there's a small hump in the x direction, indicating that it has moved forward to the right. And when you see it continue to move, is now relatively fairly constant x direction. But in the Vx direction, you can see that the velocity is relatively flat, but there's some movement. Okay, so what is meaningful in this case will be, now let's look at the y, Vy and ay. So these are what typically termed as useful physics to be analyzed. So you can see that the y actually is increasing, and the increasing is actually you can see from the y graph is actually a quadratic graph, and ay should be relatively at a value of negative 9.81, which you can see from the gradient, but not so much from the ay graph. So there's a lot of fluctuation, but behind this fluctuation from the ay graph, you need to actually look at the Vy graph to look at the gradient to determine the acceleration. So at the point where it hits the ground, you can see that there's actually several useful physics concepts that can be illustrated. So there's the lowest point in the y graph, and you can see Vy is start to increase from negative to positive value, and in the ay actually there's a very large peak, which gives you indication of the value of the impact force, because F equal to ma. So if ay is large, therefore Fy is large. And after several bounds, you can see that these are your typical secondary school graph